Welcome, everybody. Today we're working on our Unit 7 exercises. The theme for this particular unit of instruction is working with external files in Python and also learning how to work with exception handling on a rudimentary level. We have this set of exercises here, and what we're going to be doing with these exercises all the way across is all of them will involve interacting with text files. Normally what I do is I have you guys make one unit folder and you throw all your code files in that same folder. Because we will be creating text files or reading text files for each one of these programs, what I'm going to do is I'm going to create a Unit 7 folder with separate subfolders for each exercise, just so that we don't cross-pollute all our text files. Now, of course, if you're clever, you can put everything in the same folder and not mess it up. But I think if you look back at it later when you turn it in, it makes more sense, at least to me, to folderize everything. So step one for us today is going to be to create your file structure to work with. So file management first, always, right? Know where your stuff is. So I'm going to my Python class here. I got a 26 Spring folder. I'm going to make a new folder called Unit 7. Following my standard naming conventions. And then inside that folder, I'm going to create folders for each one of the exercises. And I'm going to do this preemptively, right? And you can do this any way you wish. I'm just going to name them like this. I'm going to do 7.1, 7.2, and what are the others? 4 and 5. And okay, so you guys might go like, you can just do that later, or you can do it from within your software. I'm like, yeah, true. But you know what? I like kind of setting up my framework first, and then I can just drop right into it, and I'm all set to go, right? The other thing that I'm going to be doing is I am going to be working in Visual Studio Code today, not in Spider, right? And this is kind of an encouragement, especially for those in the AI data program, to start making the transition to working with that product. So that's one of the reasons why I'm doing that. Because when we do get deep into the AI courses where we're coding, that's going to be our primary tool. All right. What I'm doing right now is I'm going to open my Explorer side tab here, and I'm going to open the folder I just created, which is out of my Google Drive. So I'm going to find that spot. And this is good. I'm in the root of the folder. And so what that'll allow me to do is I can see each one of the folders. And now I'm going to start with exercise 7.1. So I'm like clicking on that one so it's highlighted. And then I'm going to create a new file. And I'm just going to call it exercise 7_1.py. And I could call it something else, but that's what I'm calling it. All right. We will get into coding this one, but we are going to take a 5-minute break because we're already halfway through the class time. So let's pause for 5 minutes and we'll come back at approximately 12:48. So I'll see you guys in 5. All right, welcome back, everybody. We're going to continue now and start on these exercises. We're going to be doing exercise 1, 2, 4, and 5. And let's read the first one. And you can see the first one's in the form of pseudocode, where it has a basic set of instructions, a task list, right? And this is the kind of thing that programmers do, by the way, right? And when I write code, I often kind of sketch out, if not either on paper or electronically in my mind at the very least, like what steps I need to take to make something happen. But I will tell you, and I'm just going to go back to like why we learned how to do pseudocoding and flowcharting at the beginning, because sometimes when the problems get really super complex, there's no way you can remember all the steps you have to do to make things work. And if you can solve some of the basic mechanics in advance of coding, it really helps the coding go a lot faster, right? So we can think of this as kind of our script here for writing the program. So what I'm going to do is I'm going to copy that set of instructions, and then I'm going to paste it into my code in the form of a comment. So that's the first thing I'm going to do here is that here's the instruction set, basically right there. Right. I am also going to kind of minimize my AI agent window and my folder window here a little bit. But the basic instructions are open a file with the name hello text, store the message hello world in the file, close the file, open the same file again, read the message into a string variable, and then print it, basically to prove that you did it. All right. So notice that it does say that you need to open a file with the name hello text. So let's deal with that first. And I'm going to drop back down to my file system here for this. This is exercise 7.1, which is where I have this program stored right now. So this is where I want to create it. Now, I can actually go into Visual Studio Code and create the text file there. That's a possibility, right? So some of you might do it that way, and I'm totally okay. And what I mean by that is you could just come up here, say new file, and call it whatever .txt, and there it is. And yes, you can edit it right here, right? So that's one way to do it. If you're working from the file system level, though, what you can do instead is you can right-click, right, and you can do new. And be mindful of the fact I'm on Windows 11. I assume most of you are, but some of you might still be on 10. And then from the new menu, I'm going to choose text document and then give it the name that is being asked for, which is hello text with a lowercase h, right? And now case is important here, as is the file extension. And I want you to guys to be mindful here that my file system is set up to allow me to actually observe the file extensions. By default, Windows does not do that. So if I go to my options menu here in the file manager, and then go to, let's see, tab number 2, by default, this checkbox right down here that says hide extensions for known file types in Windows, by default, that is turned on. Right? It might be and probably is turned on your system. All right, so I'm going to show you what that does. Take a look at my files in my folder now and notice that hello and whatever, the .txt went away. You guys catch that? Interestingly, the Python file did not drop the extension. I'm not really sure why that's the case. Maybe it's not registered in the path statement or something. It could be the concept. But if you're in this position where your file system does not show file extensions, and then you go ahead and you create a text document and call it, some nonsense, you do not see the txt at the end of it, right? You don't. And if I flip that switch again, so I go to options, second tab, hide extensions, uncheck that, click apply, say okay, right? Now I can see them. This is the mode you want to be in. If you are in the other mode and you add the .txt, then what you end up with is hello.txt.txt, right? You get 2 file extensions, and that's different than a file with 1 file extension. So please be mindful of that. And if you get stuck on that, let me know. But if you want to see like what happens, right? So here's the option switched back on. And then I create a file, right, called hello.txt, and it allows me to do it because in truth, it is a different file. And you see that when you uncheck that box, basically. So notice the one I just created has 2 extensions, not good, right? And by the way, when Python is looking for the file and I type hello.txt, it's going to find this one, not that one. All right. So I created these text files with a right click, right? Or maybe I created them in Visual Studio Code from there. But in truth, if I open hello text, and this will open in the default text editor here on my operating system, which is Notepad. And you can see it's this tab up here, and you can see that it's blank. Okay, so I'm just going to leave this open, and then we'll come back and we'll see if the contents change, right? Because that's going to be one of our goals. All right, so I'm just going to get that out of the way, but just putting it out there. Here are the instructions we're supposed to follow. So open a file, store it, close it, open it again, read the message, and print it. Okay. Seems like some pretty simple steps there. All right. So we can handle this really, truly a number of different ways, right? So generally speaking, if I wanted to open a file, right, I can do something really goofy like this. And let's just say I call it whatever file. And by the way, this is not part of the exercise. This is just an example. And then I want to open a file. I basically would just use the open command. And inside the parentheses, you remember from the lecture stuff, the first thing that we would put in there is the file name. And then I can hard code it, right? So I could just say hello.txt like that, put in a comma, and then I want to be able to write to this file. So I use the W switch.
You still have a blank text file in front of your screen.
Okay. That's not what I'm seeing here. Melanie, are you seeing the same thing?
Okay, no, I've got it.
Okay.
I had a blank text file.
Yeah. All right, gotcha. All right. So it wasn't me, it was you. Right. That's okay, right? All right, so this is kind of the general approach. And this simple command will open the file for writing, right? And this is the approach we will generally use. Now, very often, programmers get very uncomfortable with the concept of like hard coding. So what we often will do here is we'll use a variable. And in this case, I'll just use a variable called file name. And so I'm going to pre-create that variable. I'm just going to come up here and say file name equals, okay, what file are we opening? How about hello text? Okay, so hello.txt. So then that will appear here, right? Now, I don't want to store my file in something called whatever. A real common thing to do is when you're dealing with external files, there's kind of conventions programmers use for naming things. So if like a file is like inbound only, we'll call it an in file. Like we only use the information inbound. If I'm going to take that file and push it back out to the file system, often I'll call it out file or something to that effect. And it's really up to you what you call things. It doesn't really matter, but I would caution you to call it something that makes sense. What I've been doing, at least in my examples in the past, is sometimes I abbreviate. I just go out F for out file, right? And the other thing that we want to do is we want to put a message inside the file ultimately. So what I'm going to do is I'm going to pre-configure a message, right? Just going to be a variable with some text in it. And they want us to do hello world, but that's kind of boring. So I'm going to say hello Racine, Wisconsin. Yeah, that's fine. Something like that, right? It doesn't matter what the message is. The point is that we're typing up some text. Okay. So now if I want to write back to that file, right, I keep in mind this file got opened here in write mode, and now it's going into this variable. So the file exists, I read it, and it's in a variable. Remember I said you could put anything in a variable? There you go. There's an example of it in Python. So now whenever I want to do anything to the file, I simply refer to the file by name, and then I can run some of the methods that are attached to file handling. And in this case, I'm going to write my message to the file. And then I will take that out file, out F, and then run my close function. And we're not quite done with the program, so I don't want you to think that this is all of it, but I just want to demonstrate how this works. So I'm going to run this now. It's going to open the file, right? Assuming the file exists, right? And then it's going to write that message in, and then it's going to close the file. All right. I'm going to do Control S to save. And I'm not sure. Oh, and here's me totally screwing up. Where did I type my code? In a text file that's irrelevant. All right, so please don't do what I just did. I typed it into a file called whatever.txt. It really should be here. So, all right, there you go. And now it's color coded. And I didn't even catch the fact that it wasn't color coding. Isn't that interesting? So don't get burned by that like I just did. All right. So I'm gonna save this. All right. So now the program file is ready, and I'm in Visual Studio Code, so it always wants me to select my Python interpreter, and I'm just going to use my base environment here. But now I can run the code, so I'm going to hit the run button. The console will pop up, and where's the output? Well, there's no output. Okay, why is there no output? Because I didn't tell it to output anything, right? There's no print statement here. You guys catch that? So what am I going to see in the console? Nothing. Yeah, nothing at all. All right. Kind of boring, but okay, let's go back to our file system now. Open up this folder again if you closed it perchance. And now you can see that this file, hello text, you notice it's no longer 0 kilobytes, now it's 1 kilobyte. And so if I open that in Notepad++, hey, there's my words written into the file. Now, mind you, if you're working in an environment like Visual Studio Code and you have this little sidebar here with the folders, I can also look at the file here. Right. So that's one of the nice things about working with a product like this. It does work with plain text files very beautifully. All right. We're not done though yet. That was just kind of step one to show you that I can open it, write something into it, and then go look at the file and make sure that it happened. All right. But a couple things are going on here because we have additional steps. So we actually completed this step and that step. Now we need to open that same file again. But before I get to that point, I want to talk about try except statements because here's what might happen. If I was writing this program, and let's just say I come up here, and actually let's get rid of the try. I come up here and I change the file name to something that doesn't exist over here, right? And I'm going to save this and run it. I want you to notice real carefully, there's no red underlines in my program. Syntactically, this is completely correct. Logically, it's incorrect because there's no file named hello2 text, right? So when I run this, watch what happens. Do you guys pick up what happened? This is very interesting effect here because I'm trying to open a file that doesn't exist. Did it fail? No, what actually happened? It just built the file and put the same words in it. Isn't that weird? Right? Because this is what the write switch does. So like if the file doesn't exist, the W switch will create it. All right. Watch what happens though. If I change this to a read only to an R switch, and then let's try a different file name. So we're only reading it. So it will create nothing, right? The W switch will create it if it's not there. This is only going to read it. Here's a Control S. Here's the run. Uh-oh. Colored text, error, right? And it tries to say, and notice once again, no error messages up here. No highlights, no red marks, no, warnings or anything like that. But in the runtime, so this is what we would call a runtime error, right? It's finding line 13 and it points out the line. I'm trying to open this file in read-only mode. And here's the error message. No such file or directory hello3 text. Okay, so the program failed. It didn't write anything and it stopped dead in its tracks. It didn't go past that point. So it got up to here and it quit. So this is why we use exception handling. So the way that we work with exception handling, by the way, is we use the keyword try, right? Then I'm going to take all of this code and indent it. Do you guys catch that trick I just did? I highlighted 3 lines and hit the tab key and it moved all 3 at the same time. I didn't even have to like grab the whole line, just part of it. Very slick trick, by the way. So now all of this code is inside the try block. And then of course, when we're doing something like this, we want to set something up so if there's an error in the processing, and this type of error happens to be what we call IO error, input output error. inbound information or outbound information. And then I can put an error message on the screen, and I can tailor this any way I want. So I could just say error, file does not exist. All right, let's try it like this, right? So I'm going to save it. I'm going to run it. Notice no bad error messages except for the one I created, right? More importantly, if this program was doing more stuff down below here, it would still keep doing it, right? So we're taking a spot where the code might fail. We put that into a try block. Then if it does fail, the accept block kicks in and does whatever action we might need it to do to handle that situation. So if the file does not exist, think about it. I might even want to put this in a big loop and then give them a chance to go back and try again, right? Especially if they're typing it in or whatever, right? So this is a very rudimentary example, but an important one nonetheless. All right, so still we're in the situation where we've completed basically these 3 steps. Now they want us to open the file again. All right, in principle, that should probably be in a try block. Now, I switched this to an R. It really should be a W, so I'm going to put it back. And then down here, I'm going to set up a new try block. And then what are we going to do? I'm going to read a file in. So I think of that as an in file. So I'm just going to call it INF for short. I'm going to open, what am I opening? The file name that I declared above. But this time I'm opening it in read mode like that. And I do want you to notice that as I'm putting in this parameter, I want you to notice there's a whole bunch of other choices for this too, but we're going to stick with read and write because those are the basics for right now. Right. Now, I've read the file in to memory, so it's all stored in this variable. Now I want to go through and I want to take the words that are in that file, however many lines of text there are, and then store that in the variable before I print it to the screen. So I'm just going to call my variable words. And what I'm going to do is I'm going to take that in file and I'm going to run the read line method on it, which reads the file 1 line at a time. Each line of text in the file will become a string stored in a Python list, right? Now, at this point, we're only going to have 1 line of text, but doesn't matter. That still works. Then, of course, I opened the file, read the information, and now I'm going to do in file close, right? Release the file back to the operating system. I have a try block, which means I need an accept statement here. And once again, I'm going to do an IO error because we're working with inbound and outbound files here. And then what did I type last time here? I typed error. Oh, and I even got a little bit more persnickety about this here, which is error file name not found. So like I can actually regurgitate the name of the file back to the user. Right. So that might be helpful for them. And, you know, if you wanted, you could put it in double quotes. You could do backslash double quote, backslash double quote. So there's quotes around it, right? And in order to make this fail, of course, that file would have to not exist. That file does not exist, right? Now, think about this. If I run this code with that file name, the W switch will create it, right? So when I get down to this try block, if I've created it up here, this one will never fail, but it's still safe to put it in a try except block, right? Because what if we ramp up the technology at some point? Now, ultimately, after we've read it in, we've split it into all the words that are listed. Then we're just going to like output it to the screen. And this is just going to be a simple print command. So we're going to come back to the margins here and do a print. And this is what I did, right? The file contains words, right? And if it was multiple lines of text, it would break it into a list, but there's only one thing. Let's see what it looks like when it runs. So I'm going to save this. I'm going to run it. And I'm getting an error. Notice the error. It says, in file read ein. Should be read line. Don't panic, right? I just mistyped one character. It's pretty interesting. It didn't throw an error up here. Saving, running. So the file contains hello Racine, Wisconsin. Yay, it worked, right? To make it a little more interesting, if you want to play with it a little bit, we could have a second message. We can create another new file. Let's call it hello4. Oops, my numlock. All right. And so this time it will write the message, and then we'll have it write message number 2. We'll save that. So now it's going to write 2 lines of text. We're going to run it. And then you'll see that line number 2 ended up on line number 1. Why? Well, because when we write to it, it's appending to the end of the file, which doesn't necessarily put in a new line character. So if I want a new line, I put that character in. So now I'm going to do a hello 5, right? And I'm doing that so I can make sure it's creating a new file each time. So there we go. Now where did it go? Right. And this is where it gets a little weird. So like you go in there, well, no, line number 2 is there. Why didn't it print down here? I'll let you figure that one out on your own, right? The reality is that this is outputting to words, right? And I'm just outputting the first part of words, you know? So if I like try to figure out what data type words is, it should tell me that. This is a fun little thing. I mean, we're basically opening files and writing simple little messages to them. You know, this second message here, I'm going to say is, you know, kind of functionally irrelevant, really. But I think it's pretty interesting that we can do this piece of it and kind of manipulate the file in just that way, right? When I do include this second message here, you know, there's a mechanical thing that's happening in the background that's not really showing what's going on. I am on hello 5. So when I look in here, I do see the text that is being added. The question becomes, why didn't it print the separate line? Right. And if you guys want to investigate that or ask your AI engine to solve that problem for you, hey, you know, ChatGPT and Copilot are sitting right here anyhow, so you can just ask right there if you're curious. So that's the first exercise. I'm going to now switch over to this other folder here, and I'm going to create a new Python file. We'll call this one exercise 7_2.py. And let's read the instructions on this one. I think I have them queued up over here. All right. There it is. All right. It says, write a program that reads a file containing text. Read each line and send it to the output file, preceded by line numbers. So if the input file is, for example, Mary had a little lamb, yada, 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 then what we're going to do is we're going to open that file. We're going to add this information to the beginning of each line. So it's like / star space 1 space star / space to each line, and then write it back to the file. And then we're going to ask the user via a prompt for input and output. Okay. Now, once again, when we're inputting and outputting files, should ideally be in a try block. If we're interacting with the user, ideally it should be in a try block. You know, so I'm going to kind of demonstrate it like that. We do need some information to start with, though. And if you want, what you can do is you can pre-create the file to go in there. And what I normally do here is I go back a semester and grab from like the previous semester, basically. wait, wrong unit. We want to be in 7. And you can see I have, let's see, let's open up this file here. There's Mary Had a Little Lamb, right? So what I'm doing is basically, I'm going to send that to you guys in the chat. So those of you that are here in the session, you can grab that file so you don't have to type it. Take that file and store it in your folder. I'm going to do the same thing. So I'm going to copy it here from my file system, and then I'm going to go to the 2026 folder. And I'm going to place that file in there. Okay. I did notice back in that other folder though, and so this is where I'm being kind of goofy about this. I'm like, why do they have all those other files? And it looks like this one, oh, I see. I use Blackbird instead of Mary Had. You know what? I like this better. I'm going to use Blackbird instead. So I'm gonna copy this file too. If you guys want to follow along with me, I guess I'm going to use this one. So I just threw that one in the chat too. But I'm going to copy this file and bring it over to my other folder. And this is why it helps to be organized, folks, so you can find things, right? And of course, all that rigmarole, and it ended up not copying anyhow. So we've got to go back one more time. Or I'm going to be smart. Save it from here. I don't know if that's smart, actually. It might actually be more work. I will save it here. So I got 2 files I can process now. So I got one that has the first stanza of the Beatles' Blackbird song, or our traditional little poem, Mary Had a Little Lamb. So both those are both there. All right, let's go now back to our coding engine here, and let's get started. So I'm going to build a big try block here. And for now, I'm going to put the pass statement in. And then we'll do an except statement at the bottom. And then I'm going to do a pass statement here too. I'm not sure what I'm putting in there yet, but you see I'm building my structure first. And the pass statement allows me to basically leave the stuff empty until I put stuff in and not throw error messages. Where if I get rid of this, then you see a little red underline, right? That's kind of the thinking. All right, so in the try block, what are we going to do first? We're going to prompt people for the input name of the file. So I'm just going to ask them for the input name. So step 1 is going to be this, right? So enter the input file name. Of course, this assumes we're in the same folder, right? And keep that in mind as well. I'm not really doing demos here where we're going like across different folder levels. As I mentioned during the Kahoot, it is possible to also invoke the operating system library. So you can do import OS, and then it brings up the file opening and saving tool that's native to your operating system. So you can actually go hunt for your files instead of typing them in, right? And that would really be the more correct way to do it. But you know, part of this is to have the potential of the user failing to enter it correctly, which is why we're putting it in the try block, right? Then we'll go into, so I grabbed the name of the file, but now I'm going to grab and open the file. So I'm going to store it in my in file, and I'm going to call the open method. And what am I opening? Well, the file that I typed into input name is what I'm opening. And then read only or write? Well, if you read the instructions, I'm supposed to read the file in, make changes to it, and then write a new file is what we're doing. So here I'm just going to use the R switch, read only. So that has a potential to fail. All right. So if it fails, well, what's the accept statement for that? Well, now I can start to think about that, right? I can say print. And by the way, this is an IO error, right? So you don't have to put that in, by the way, but it's considered good practice. And then what's my error message going to be? How about let's do an F string here, and I just say, you know, error in all caps, input file, and then we'll name it. Was it input name? Not found in this folder, or something like that. And if I was a good programmer, I'd write a loop and make them do it again. But that's a little beyond my scope here right now. I was worried more about the file handling. All right. Now, once we get past this point up here, though, so let's say the file does open correctly. The next step is to prompt the user for the output file name. And that could potentially fail too. So now I'm doing a try block inside of a try block. And so once again, I'm going to do a pass statement here. And then that's also going to require an accept statement. And then I'm going to put a pass here as well for right now. So let's work on this piece. We're now going to ask the user, what do you want your output file name to be called? And I'm going to call that output name because I called it input name before, so that makes sense to me. And then I'm going to do my prompt, and I'm going to say input, and what's our prompt? It should be enter the name of the output file. And if I was a really good programmer, I'd say e.g. example given, output.txt or something like that, but I don't want to do that for both. So they're going to capture that. And then what are we going to do with that? Now we're going to open that file in write mode. Remember, if I open the file in write mode, what does it do? It creates the file if it doesn't exist. So the out file will open the output name in write mode, W. So in principle, this should never fail, but you never know. So that's why it's in the try block. All right. The other thing that we're going to do at this spot is when we're changing this file, one step at a time, we're going to put a number in there. So we're going to number the lines in the file. So I'm going to create a variable here to kind of track that. I'm just going to call it number. And the first number we're going to use is 1. So I'm just hard coding that here. Then the process, I want you to think about this. I'm going to read through each line. I'm going to append, that / star space, the number space star / space, right? And I'm going to do all that. And then that's going to repeat. So I'm going to put that all in a for loop. So I'm going to say for each line in the in file. So I'm going to traverse the in file here, right? I'm then going to take my out file and write to it. So I want you to think about conceptually what's happening here. We're going to read through each line of the in file, and then I'm going to use that to write to the out file. This is bizarre, but it totally works. And we are going to f-string this, right? And then inside here, we're going to go / star space. Then we want to put in the number. So your inclination would be to do this, but because up here it's a number and we want it to mathematically increment, I'm going to do a string conversion on this so that it outputs correctly. So I'm going to do str number. And you know what? I don't know that this is 100% necessary, but I've run into situations where it was. So then we'll do a space / and a space. And then in curly brackets here, I'm going to type in line. So what this is, right? This variable here is the line that I just read in from the in file. So the for loop reads in the one line at a time from the in file. I'm taking and I'm writing this to my out file plus whatever I read in from the in file. So this with the for loop is what's reading the in file in. Isn't that weird? So simple. Really, truly very simple. Then every time I go through the loop, I'm going to want this number to increment by 1, right? So I'm going to say number plus equals 1. So it'll add 1 to the number each time, except you do have to spell it correctly. And I recommend you have a space there. because otherwise it won't work. All right, so that will read in each line, add the text we want, increment the counter. It'll run until the file is done. So if there's 1,000 lines in the file, it'll add numbers to each one. If there's 4 lines, it'll add, numbers to each one of those. Now we're done looping and stuff, so I'm going to come back one indent level. I am going to take the in file and close it. I'm going to take my out file and close it. Right. Releases it back to the operating system, right? And then, okay, this is the goofy nerd that I am. I like to do goofy stuff like this, right? I'll drop in a message that tells me that it's done, because this isn't echoing anything to the screen as it's working. You know what I mean? We don't see it doing the work in the background. We just assume it's working. So if this message comes up on the screen, file processing complete, your files have been changed, in principle, it should have worked. Or at least it will prompt me to take a look. All right. In the accept portion of this, I still have a pass statement. So what should go here? So if I try to, let's say, enter the name of the output file. Okay, so here's one possible thing that could happen is I might put in an output file name that already exists, right? And so that's one thing that might happen. And I think last time I typed this message, now when I think about it, this message isn't really the right one to put in here. Sorry, that won't work because your input file did not exist. And actually, that's not really what the situation is. Sorry, that won't work because why? The file name is not unique. How about that? The file name is not unique. Yada, yada, yada. And once again, if I was a good programmer, I would put this all in the loop and make them do it again, right? So you can see the complexity that you can add to this pretty quickly. This is the whole program right here. 17 lines of code, folks. So let's do Control S. Now, in our folder, I want you to be mindful that I'm going to try it with both of these files. So one is the Beatles Blackbird, so I'm inputting input-bb.txt, and then Mary-lamb.txt. And it is important that upper, lowercase, special characters, every character is exactly the same. Right? So I'm going to make it work correctly. So here we go. All right, so it's prompting me now. Let's pull the console up a little bit. Enter the input file name. Let's try it with Mary Lamb. Mary-lamb.txt. All right. Enter the name of the output file. Mary with nums. How about that? txt. So when I press enter here, it'll open the file, read line by line, add that text at the beginning with an incrementing counter, save it, close both files, and then I should be able to see it. All right, so here's file processing complete. Of course, we see nothing on the screen here, but hey, I see it over here. And when I click in there, here we go. There you are, right? There's an example that it works. Now you can try it again, right? So if I want to run this again, let's go back to 7.2 here. Let's run it again. Let's try it with the other file. So I'm going to input-bb.txt, and that's the one that's got the Beatles Blackbird first stanza in it, or whatever you want to call it. And let's call it something simple like output-bb.txt. Press enter. It says it's complete. Did I see it happen? Oh yeah, it happened. It just was out of view. So I can click on that here, and there you are. So we took it from this to that. And once again, if I had 1,000 lines of text in here, it would have numbered every line and saved the file. And truly, if you guys want to experiment with bigger files, just try it. Python will handle it. It can handle very, very large files for sure. All right, let's keep moving along here, folks. Next exercise is 7.4. Let's go read about that one. So exercise 7.4 says, write a program that reads a file containing 2 columns of floating point numbers, prompt the user for the file name, and print the average of each column. Uh-oh, there's math, right? All right, so just to kind of aid in our stuff here, first I'm going to create a new program inside of 7.4 here. So I'm going to call this exercise 7_4.py. And then back to my old file system here, where I'm going to go back to my previous semester. And I have this file here, which I'm going to copy. And actually, can I just drag it down here? Yep, that works. All right. So here's my input file. And I want you guys to notice here that I do have multiple files. And in fact, we're going to play with this with a couple different files. And I'm just recalling now that I had 2 files. So the original file that I used to work with, right, this is 2 columns. And you'll notice I have 1 column of just plain integers and then another column with floating point numbers. And then if I like break down this file, and this is like one of those goofy things you do with text files, data people, right? Notice how I'm like arrowing through the file. And when I get to the number 1, I hit my arrow key once and it jumps. This is a tab stop in here, right? And often data that's put into files that's made into columns, people either separate the data. I'm just going to show you, you can separate it with commas, right? That's called a CSV file typically. Or you can separate it with tabs. Tabs and commas are really common separators. Tabs tend to come more out of databases, CSVs out of other formats, but a very normal thing to do indeed. All right. So the goal will be to read this in. And I want you to think about what that's going to take. We're going to have to read each line, break it into its individual words, if you will, even though they're numbers, convert those words into numbers, and then do math with the numbers selectively. Right? So it's kind of a tall ask, really, right? You know, there's a lot going on here that we're kind of breaking apart. So let's start with some basics here. So I'm going to bring up 7.4 here and start to build some code. We are going to start with a try except block. So I'm going to put in a try. I'll type in pass. I'll put in my except. I'm not sure what kind it'll be. In fact, this one I might just make a generic one just to show you that it still works. And we'll do that. All right, so let's start with some basics. We are going to prompt the user for a file name. So here comes step 1. Enter the input file name. And we'll probably type input1.txt to start with. Then on that file name, we're going to run the strip command. And I want you, and I'm just going to, for the point of like demonstrating this, remember the strip command does what? Removes leading and trailing spaces. Okay, I've looked at my data set. I really don't need this. Okay. However, right, so here's the big however, right? It's not really a bad idea to throw this in, even if you think you don't need it, because later on, if you take your code and you throw a different data set in it and it doesn't have good data, this might help to deal with it. So I'll call this optional, but a good idea, even if it's not being used, right? So this is just kind of good practice, right? And programmers get into those habits. Okay, so now we're going to have an in-file variable. And what am I doing? I'm going to open my file name. And we're read only here. We're just reading it in, right? Because what we're going to do is we're going to read it in, do stuff to it, and then write it back. Or are we even doing that? No, we're just going to extract the numbers and average them. So I don't need to change anything. So it's a read only thing. All right. For my pass statement here for an error, the only thing that could possibly happen here is that the file's not found. So instead of pass, I'm just going to say file not found. I do want you to notice I'm not indicating IO error. It will still work, by the way. Now, the reason they have different error types, if you're curious, is to handle for different situations automatically. But this is a pretty low level. All right. Next, we're going to set up another try except block. So here's a try. Here's my pass. Here's my accept. Here's my pass. Okay. Once again, same structure. And once again, twice in a row, I type semicolon there instead of a colon. So it just shows that once a year, I make a mistake. All right. First thing that we're going to do is we're going to set up a bunch of variables here. So I want you to think about this. If I'm I'm setting up for 3 totals here because I'm going to add a third column in just a moment. But if I'm going to come up with averages are, how do those work? I add up all the numbers, get a sum, and then divide by the number of total numbers that I have to get the average, right? So I need variables to hold the totals. Total 1 for the first column, total 2 for the second column. Later on, I'll add a third just to show you it's easy to scale it. And then because we're going line by line, I need to count the number of numbers that we have. So I have a count variable. All of them have been preset to 0, right? Hopefully that makes sense to you. Then we are going to read in all the lines. And yes, I am in copy paste mode right now because we're short on time. So I set up a for loop. So we're going to read each line one at a time from the in file. Notice we're going to split the line. So this is like, once again, one of those lecture points where the split command comes in. What that does is it looks at a line of text, finds a space or a separating character, and then takes each item in that line and puts it into its own position in a Python list. So parts is therefore a Python list with each individual item from that particular line of text put into separate containers. Once again, I'm gonna comment out total number 3 here, right? Because I'm not gonna work with 3 columns right away. Once we get past the split command, I then take whatever's in the first position, position 0, I convert it to a floating point integer, or it's floating, that's a contradiction, right? I turn it into a floating point number, and then I add it to total. Then I go to the second position, position 1, right? Turn it to a floating point, add it to the second total, then I increment by counter by 1, and all of that loops until it's all the way through the numbers, right? Once the for loop completes, right, we'll come back one indent level here, and we'll close the in file. So let me pull the console out of the way here. So here's our code so far in that try block. Now we got to do all the math, right? So we read through, we did our totals, we converted numbers to get the totals. Now we have to calculate the average for each column. And once again, I'm pasting in the 3-column version, but I'm commenting out the third one on purpose. So we're gonna take the total, divide it by the count for each one of those, and we'll have the average, and it will be stored. Then we will simply display the results. So here it is. And once again, for each one of the item number 3 here, I'm commenting those out until I deal with a file that has to be column. I'm going to start with a 2-column file. All right. Then I have my final accept statement. So if the whole thing fails, right? And keep in mind, this is part of this thing here, right? If any of this has a reason to fail, you want an error message for your user. And this is the snarky error message I put in last time, and I grabbed this terminology from my offspring, which when they were youth would always say epic fail, and it kind of stuck in my brain for eternity. So, right. And it's a little funny, hopefully that error message never triggers. All right, I'm going to do a Control S to save. Be mindful, it's the input text. The plain one has 3 columns. Input 1.txt has the 2 columns. So I'm going to run this one first. All right. So it is going to prompt me for that file name. So I got to be precise about typing it in. Here's the run. Okay, it's prompting me. Enter the input file name. Okay, you know what? I'm going to make a mistake on purpose. Input text input 2 text. All right. There you go. Error, file not found, epic failure, program stinks. It worked. Right? Neither one of the code blocks happened. All right, let's be more serious this time and get it to work correctly. So I'm going to say input 1 dot txt. This is the 2 columns, right? So I went in there, it gave me a total of 21 and 15.7, a count of 6. First column average is 3.5, second column average is 2.6, and blah, 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 blah. All right. Do I take that on faith? Never. Right? You know, whenever numbers are thrown at you, do not take them on faith. Backtrack them and figure out if they're for real. 1 plus 2 plus 3 plus 4 plus 5 plus 6. So we got 10, 8, 21, right? Is that what it said here? 21. 21 divided by 6 is 3.5. That's correct. All right. 1.5 plus 1.9. So I would actually put them in the calculator or a spreadsheet and check it out. Right. Once I know my program's working, we're good. This is pretty low level math, but always check your formulas, folks, for sure. I could format this one. Now, what I'm going to do is I'm going to go back to my code file now, and I'm going to remove the comments on all the things associated to the 3rd column now. And you can see me doing this item by item. And then what this should give you the idea is, all right, we're processing 2 columns of number, but I could easily process 3 or 4 or 5 or 1,000, right? Same syntax. And we could process ones that have thousands of lines of information in them at the same time. So I'm going to go ahead, save this, and now we're going to feed this file into it. So let's run it. And we're just going to put input.txt. We're going to press enter, and there you go. Now we know the first 2 numbers are right because they're the same ones we got before, but the 3rd column, if you looked at this one, this had a lot scarier looking numbers, big ones, small ones, weird ones, floating point, not floating point. But ultimately, Python still handled it just fine and processed 3 columns of data. So what we're really showing you here, folks, is Python has this capability to read in numerical or text information from external sources, process the information, turn it into little bits, convert it to the format it needs, do math with it, and basically process it, right? Very, very powerful stuff. Might not seem like it, but the stuff we're doing here really gives you some pretty immense capabilities moving forward, right? So successful. All right, let's move on to exercise 5. We are officially over time, so you guys are free to go if you need to, but I'm going to keep coding till I'm done. We should be done in about 5-10 minutes here. So, all right. Next one says, write a program that asks the user for a file name and then prints the number of characters, words, and lines in that file. Okay, wow. All right, that's pretty heavy. All right, let's set ourselves up to work first. So down here in the folder I created 7.5, let's create the program file first. So exercise 7_5.py. And then I know I have data files associated with this, so I'm going back here to last semester. And it looks like I have Blackbird from the Beatles here. So I am going to copy that, and I'm going to move it into this folder as well. And then if you click on it, I want you to notice this is the whole song. Yeah, right? So this is the entirety of that Beatles song. And if you guys aren't familiar, you should check it out. It's a pretty cool song. Got to see Paul McCartney perform it live this past fall, and it was quite a thrill. One of the best video highlights of the evening, by the way, because he sang it by himself on acoustic, and they had all these video screens, and the Blackbird flew, and yeah, it was pretty epic. You get to see him live. Go do it before he dies, because it's probably going to be soon. You know, knock on simulated wood. All right. Let's get into coding this one. And the first thing I'm going to say before we even get started with this is kind of a weird thing, but if you use a program like Microsoft Word, right, which a lot of us do to create documents, and I'm just creating a blank document here, and then I take that that Blackbird file right? And I just copy all this text and Control C, and then come back over here and Control V to paste it in. So there's all the text. And this is really kind of interesting thing about Microsoft Word, and a lot of people aren't even aware that it does this, right? You guys are typing a paper for your English class, and the teacher says, minimum 500 words, or something like that, right? Did you ever get one of those, or 5 pages or something crazy like that? Well, did you guys know that Microsoft Word has this little tool down here in the corner? Like if I click on it and it brings up this panel, and notice this is 1 page, 124 words, 524 characters with no spaces, 630 with spaces, so many paragraphs, lines, blah, 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 blah. And it does this automatically in the background. So the code that we're about to write performs these functions, right? So somewhere in the background, Microsoft Word's got code like this that automatically generates it. Why do we do this? For college students that have to get to a certain word count, right? I did have, it's kind of weird to say, but I did have teachers when I was in university that had these like crazy strict rules, like if it's only 499 words, you're getting an F, like weird stuff like that. And it's got to be a 1-inch margin. If it's 1 1/4, it's out of here. If you're using 14-point font, you're done, that kind of thing. And you guys don't have to deal with that these days. In fact, most of your instructors probably don't even care. It's kind of the way I look at it. But what we're going to do is we're going to use Word as our fail safe. Like, like I say, validate your math. I'm using Word to validate my word counts. You guys feel where I'm going with this? All right, so back in the program file, I'm going to begin by creating 3 variables because I want to track now how many characters, how many words, and how many lines are in the file. That's what we were told to do. 3 variables, all preset to 0. Right. Now we're going to start doing our processing. We are putting this in a try except block. So once again, as I've been doing, I do a try, a pass, an accept, a pass, and then we'll build the stuff in. Okay. All right. First step. We're going to read in a file. Stored that in a variable called file name. Also, I'm going to need a counter here at some point to start counting things and figure out how many times I'm going to allow the user, not here's a spot where I'm actually going to allow the user a chance to type in the right name if they type it in wrong. I wasn't so polite in the past, right? But now, but in reality, you don't want to like have the program stop and throw a snarky error message if somebody mistypes something. So my thinking is, let's give the person 3 chances to get the file name right, and then we can get snarky. And call them an idiot or something. All right, but we'll have a counter that keeps track of the file name attempts. So what I'm going to do is I'm going to run a while loop here, right? So here comes the loop, where I'm going to check to see if the file name is not empty. So they didn't even type one, right? So that might be one error. It's like they just pressed enter instead of typing the file name. And as long as the count is less than 3, we're going to let them try again. So if the file name didn't go in correctly, and the count is less than 3, then we're going to put an error message on the screen. We're going to say, file not found. And I would say try again, but that's probably good enough. File not found. Then what else would happen? Well, if it didn't get it right the first time, let's give them another chance. So I'm going to take the prompt and drop the prompt in again. Okay. Chance number 2, this time. And then every time they try, we're going to increment our counter by 1. Just add 1 to the counter. So this is try number 1, try number 2, it'll loop. By the time the counter reaches 3, it's not going to happen anyhow. So this is all the code it takes to do that. After we've done that, we are going to take the in file right? Where we're going to store the incoming file. We're going to open it. What are we opening? Well, the file name they typed in. And do we need to change the file? No, we're just counting the stuff in it. So read only is fine. And that has the potential to fail. But I would say that if you successfully open the file, you might want to do something like this. This is what I did last time, is I just say file successfully loaded. Give them some feedback on the screen that it works, right? Hopefully. Well, actually, I could see a problem with this, because could they fail 3 times and they would still get that message? All right. So now I'm thinking, you know, maybe in an if statement, whatever. But all right, I'm just doing that anyhow. All right. So now that we have it loaded up, we're going to say for each line in the in file, we're going to do the following. We're traversing the file now. And every time it reads through a line, because the for loop is going to do it automatically, we're going to increment our variable called lines by 1. So now it's 1 line just happened. Then we want to count the characters. All right. So with this one, we're going to kind of do the same thing, but here's how we're going to do it. We're going to look at the characters in the line. Every time we read in a line, it's reading in 1 line of text at a time. So what it's conceptually doing is this. First time through, it reads in that. And then what it does, the command that I'm about to type, is how many characters are here? Well, it depends. Am I counting the spaces or am I not counting the spaces? In raw, straight up programming, we count the spaces as a character, right? So all I have to do to get the number of characters is get the length of the line. So that's the code. So here I would say the length of the current line in memory, that'll convert to a number. That's the number of characters. Every line will be different, but characters will increment each time we hit it. Then we'll do the same with words. And with words, we're going to do the same thing, but we can't just get the length of the line. We're going to get the length of the line when it's split. So here's the concept. We're going to run the split command. The split command will come into a line and we'll go, aha, there's a word, skip the space. There's another word, skip the space. There's another word, skip the space, etc. And then each one of these words ends up in a Python list in a separate memory spot. And then when we run the split command on that and then check its length, it's checking the length of how many things are in the list. You know where I'm going with that? So it's going to count the number of words, skipping the spaces. So the command for that, and actually click here, is I'll do the inner part of this first. So I'm going to do the line dot split. So that splits the words into separate Python list positions. And then I want the length of that Python list. And this is going to be a numeric return that gets stored in words. So this goes through each line, counts the line, counts the characters, counts the words. And it keeps looping until it's gone all the way through the file. All right. We're done working with the file at this point. So coming back 1 indent, and we're going to close. All right. Now we want to put the results on the screen. Here's how I did it last time. And I did use my old non-F string approach for outputting it. So I used the argument approach for putting it on the screen. Partially I did that to get everything to line up real nicely. Right. And we should probably put something down here. This error down here will really truly trigger if the file's not around. So we'll do an IO error, and then you can say something like that. I still have a question on whether or not this is really logical. So we'll test that. We might remove it. Or if we wanted, we could engineer it into an if statement, like I said. All right. Let's do the run on this, folks. And I know some of you are still copying code, so maybe That would be helpful, like right around there. Okay. All right. So let's go ahead and run this. Here's the run. Enter the input file name. All right, let's put in something that's wrong. The only correct one is blackbird.txt, all lowercase. So I'm going to just type some stuff. Okay, what did it do? It kicked me out. Did it loop? So try this failed. I want you to think about what happened here. This failed, which threw an exception and went right to the error message. And I want you, and I'm stopping, this is dramatic pause for effect, right? Is my logic even right here? It's okay to say no. Because I'm realizing it's wrong, right? Because enter the input file name, it failed. So it jumped out at this point and never got anywhere past that code. It just failed here and through the error message right away. So is this really the right approach? This is what I'm having you guys contemplate. It's not giving the person a chance to fix it, is it? Right? It's not. Okay. So here's the thought, and I'm just going to do this really quickly here. Let's get rid of the try. Let's get rid of this. And then, all right, even more cumbersome, delete all this stuff, right? Oh, wrong direction. Okay, what is part of my while loop and what is not? Now I'm losing track of that. Okay, we end at count. This has to come back to the margin. And now I lost my mouse. Okay. There it is. Okay. Not sure what happened to my mouse there. Okay, my external mouse is no longer tracking. So I'm using my touchpad now. Technology does fail, folks. All right, we'll do the same thing here. Maybe I didn't talk so much while I was coding, I would be better off, right? All right, let's try it now. Let's see what happens. And I'm still perplexed with why this is not working. Let's try unplugging and replugging. Oh, now it's working. Okay. So I got rid of the try except. Let's try running the logic now. So Control S. Here's the runtime. I'm typing nonsense in. It doesn't like this, does it? Not at all. Right? So I need to figure out a way, right? If that file doesn't exist, to handle it, right? So the only scenario that's going to catch here, and I don't know if I'm like leading you guys to this very clearly or not. If I just don't type anything, then my logic for the while loop works. You see that? So if I leave it blank, it says file not found. And so blank is the only thing, right, that's going to work to keep that.
And you've got right now that if the file is blank and the count is less than 3, then you print file not found right away.
Yeah.
Don't you need if the file is not blank and the count is less than 3?
We're talking about right here.
Yeah, above that, right above it. Right there. Doesn't have to be a file not blank.
Okay. So Are you saying I should add a condition here, Ray? So if I said like file name,
No, I'm saying change the double equal signs to a not equal.
okay, this is
And
an
the count
interesting
is less than
scenario.
three.
All right, let's try this, Ray. I think you're onto something, and I think your coding experience shows a little bit. But now notice what it says.
Do the same thing.
No, actually, it hadn't
Worse.
it hadn't finished executing from before. All right, so here I can type in my nonsense. Okay, now I can type in a blank line, but that quits. It's like, I mean, I could say something of this effect, perhaps. And now we're over engineering it probably. I could say file name equals blank. And then we could put in an or. Then we can put parentheses around this and get really complex. So we're dealing with the blank or nonsense or 3 attempts. Let's just try this and I'll show you like what the effect of this is. All right, enter the input file name. Here's blank. All right, here's nonsense. Here's more nonsense. How many more tries should I have here? Wasn't that 3 tries already?
Yeah.
Yeah. Okay, so this while loop, real frankly, is not really a good pathway. What I'll recommend, right, is you guys probably just skip this stuff. And here's how I would re-engineer this. I would get rid of this piece. And this is a whole lot of rigmarole that we just went through, so I apologize for that. But I'm going to take all of this stuff, I'm going to indent it. You see how I did that? I just highlighted it all, hit indent. And then I'm going to build my try block around it again, because I do think that it's actually necessary. I'm going to put in my except here at the bottom. What was my message? Error file not found, which is appropriate if it doesn't load. So we'll load it into the variable, put an error message or put a success message on the screen. Right, if it fails, it's just going to do the exception statement. Then it's going to read through, do the calculations, display the results, and I think we'll be okay. Right. Now, if I wanted to do this while loop, and this is the part you guys might not see from an engineering standpoint, the while loop should sit outside the try block. That's really the solution, right? Maybe you guys aren't thinking in that regard. So here comes save. Let's do a run. And okay, so I'm going to put in something bad. All right, it just clicks out. If I put in the correct thing, and let's do that, which is blackbird.txt. All right, and it says 647 characters, 124 words, and 18 lines. How does that compare to Microsoft Word? 124 words, 18 lines. How many characters? We got a little discrepancy there. 647. I have either 630 or 524. Now, 630, I want you to think about this, is really close to 647. All right. There's 18 lines of text. Right. So this is kind of an interesting little lesson here. Right. 18 lines of text. Whenever I'm looking at this text, every time I'm moving from one line to the next, we don't see it, but there's a hidden character there called a carriage return that tells that line to go to the next one. And guess what? Python is counting it. So I can actually write code to have Python skip that. But Python is removing that. And I'm thinking here that the discrepancy is that. So Python is counting it, Word is not.
That'd be the other 17.
Yeah. And then this, the fact that the file ends, right? There's an end of file marker there too, which is the extra character. Pretty interesting, goofy stuff, right? But kind of interesting at the same time. So like when they designed Microsoft Word, somebody wrote this algorithm into it because they thought it might be useful. And it kind of is, right? So we can do our Python homework, 50 years later. All right, folks, that is the solution for 7.5. And we're going to cap things here. So that was our lesson here for today. This video ends here and class is over.